I think we take water for granted, but actually we shouldn't take it for granted, because under growing population, increasing demands, increasing agriculture pressure, we're actually about to disrupt our water resources for future generations. Yeah, water is everywhere and has been always an essential part of all life. Because there's only a very, very small amount of fresh water on Earth which we can actually use, managing that water and that water resources that comes along with it is essential in order to have a sustainable development in a world with a growing demand of water. I think the problem with water in general is everybody uses it and everyone cares about it, but no one really wants to care about it. And especially because we consume our water in our world, in the Western world, from a tap. It's something else if you go to a well and pick up your water, but I think it's often overlooked and therefore we take it for granted. As of today, the global water demand increases by approximately 1 to 1.8% yearly. 70% of that water demand is attributed to agricultural production. So in the future, with population growth, our agricultural production will intensify and thereby our water demand will be increased. But it also increases the nutrient pressure onto the water bodies below those fields. We actually need to know if those fields contribute effectively to the nutrient budget in our streams, or maybe the nutrients are retained or degraded in the catchment, so they never reach the streams, and what specific areas of that agricultural fields contribute. So if we look at the stream is a large mixture of different types of water, but this stream has actually a chemical fingerprint in it, similar to a DNA actually. It's composed of various sources, and by looking at the chemistry or the chemical fingerprint of the stream water or the isotopic fingerprint of the stream water, we can then detangle the sources, so what source feeds that stream. In particular, the drain fraction, it's a very important fraction because all the water which ends up in drains has not been undergone large reactions. It's directly drained from agricultural areas, and therefore nutrients haven't been degraded and end up directly in streams. In Denmark, they're having a difficult time to quantify the drainage compartment of stream flow. So how much water comes from drains. I hope to put a measure on that drain fraction. So I was studying oxygen isotopes in different water compartments, but they yielded mostly very valid information on the time or the age of water. I never really got into the sources of the water. So I was looking for an alternative way of describing the actual pollutant, nitrate, which yields information on sources. And with the isotope analysis of nitrogen and oxygen, we can actually put a number on the drain fraction. Combining the history, the time of or the age of the water with the chemical fingerprint, the provenance of the water, we are actually able to manage our water resources more sustainable. We can say on a higher detailed basis where water, for example, comes from, how old that is, and that information we can compare to models or even fine-tune those models so that we make less wrong predictions. And we can inform policymakers, stakeholders, and then they take action.